This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 2 of Week 5. Boilers and Steam Generation. A boiler is just a steady flow energy balance wearing a furnace. Chemical energy in the fuel becomes enthalpy added to water. We turn that balance into 3 exam tools: boiler efficiency, the fuel consumption rate, and blowdown with makeup water. Then we size the fuel rate for a real steam load. Start with the picture. A boiler is a steady flow control volume. Feed water in, steam out, no shaft work. The steady flow energy equation, which lists boilers by name, collapses to heat duty equals steam flow times the rise in enthalpy, H out minus H in. That heat is what the water actually absorbs. The fuel side is separate. Burning fuel releases chemical energy, but only a fraction reaches the water. That fraction is the efficiency. Boiler efficiency is the useful heat into the steam divided by the chemical energy in the fuel. Steam flow times the enthalpy rise over fuel flow times the higher heating value. Fire tube boilers run about 75 to 85%. Modern water tube units, 85 to 95. Rearrange for the fuel side and you get what the exam usually asks for: the fuel consumption rate. Efficiency is dimensionless, so keep top and bottom in the same energy units. The variable table for every boiler problem. Steam mass flow, given. Steam enthalpy out and feed water enthalpy in, both table lookups. Higher heating value, from the fuel tables. Efficiency, given or solved. Fuel mass flow, the answer. And the blowdown fraction, 2 to 10%. 3 of these are lookups, the 2 enthalpies and the heating value. Get those right and the algebra is a single substitution. Higher heating value is the fuel's chemical energy per unit mass, the heat from complete combustion. The Handbook lists 2. The higher value includes the latent heat of the water formed in combustion. The lower value does not. The efficiency definition uses the higher value, so read HHV from the fuel table. Methane is about 24,000 BTU per pound. Propane a bit less. Fuel oils have their own table on the next page. One caution: efficiency quoted on a lower heating value basis looks higher because the denominator is smaller. Now the single biggest trap: saturated versus superheated. The steam leaving a boiler is usually superheated, so you need both pressure and temperature to fix its state and read H out. Feed water is a liquid. Approximate its enthalpy as the saturated liquid value at the feed water temperature. Why it matters: at 600 pSAA, the saturation temperature is about 486. Steam at 700 is superheated, about 1351. Grab the saturated value by mistake, and you're off by tens, and that error cascades into efficiency and fuel rate. Always compare the given temperature to the saturation temperature before you look anything up. Blowdown. Pure steam leaves dissolved solids behind, so they concentrate in the drum. Blowdown continuously bleeds off a fraction of the water, 2 to 10% of feed water, to keep solids in check. A steady state mass balance closes the loop. Makeup equals steam plus blowdown minus condensate return. Quick illustration: 50,000 pounds an hour of steam, 4% blowdown, 70% condensate return gives about 52,000 feed water, 2,000 blowdown, 17,000 makeup. Watch whether blowdown is a fraction of feed water or of steam. The Handbook uses feed water. Worked problem. A water tube boiler delivers 50,000 pounds an hour of superheated steam at 600 pSIA and 700 degrees. Feed water enters at 230. Efficiency is 82%. Fuel is natural gas at about 24,000 per pound. Find the fuel consumption rate. The plan: look up the 2 enthalpies, get the steam side heat duty, then divide by efficiency times the heating value. Step 1. The lookups, then the heat duty. Confirm superheated. At 600 pSAA, saturation is about 486, and 700 is well above, so read the superheated table. H out is 1351. Feed water at 230, read as saturated liquid, is 198. The enthalpy rise is 1153 per pound. Multiply by 50,000 pounds an hour, and the heat duty is about 57.7 million per hour. That's the useful heat the water absorbs. Step 2. The fuel rate. The fuel must supply more than the steam absorbs, because only 82% gets through. Divide the heat duty by efficiency to get the fuel energy needed, about 70.3 million per hour. Then divide by the heating value. The boiler burns about 29.45 pounds an hour of natural gas, roughly 1.5 tons, to make 25 tons of steam. Sanity check. The fuel energy exceeds the steam duty by exactly the 18% the efficiency throws away. Report it to 3 figures, about 29.40. 4 traps. 1. Saturated versus superheated. Boiler steam is usually superheated, needs 2 properties, and grabbing the saturated value is the classic error. 2. Higher versus lower heating value. The efficiency relation uses the higher value, so match the basis. 3. Dropping the feedwater enthalpy. The boiler adds only the difference, H out minus H in, not the full H out. Forget it, and you overstate the duty by about 17%. 4. Mixing energy units. Efficiency is dimensionless, so keep top and bottom in the same units, and remember the steam flow is per hour. Bookmark the boiler pages. The energy balance, heat duty equals steam flow times the enthalpy rise. Boiler efficiency and the fuel rate rearrangement. The superheated steam table for H out and the saturated table for feed water. The fuel heating value table with fuel oil grades on the next page, and the blowdown and makeup relations. The 2 steam tables and the heating value table are the 3 lookups you'll reach for on almost every boiler problem. Tab all 3. You now own the boiler as an energy balance. Heat duty equals steam flow times the enthalpy rise. Efficiency against the fuel's heating value, and the fuel rate that falls out, about 2,945 pounds an hour for our load. In topic 3, we open the boiler's cousin, the heat exchanger, and split that same heat duty into the LMTD and NTU methods. Same first law, new geometry. Bring today's heat duty habit. It's the backbone of every exchanger problem. See you in topic 3.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.